Alright, so let's come to the last part for this section on the evaluation matrices. Before we have mentioned the pipeline for machine learning, right? Normally we have to train a model and do the testing, and we also want to evaluate the performance of a model, right? With some evaluation matrices. For all the tasks we have mentioned before, including the classification, regression, and clustering, we have to define some evaluation metrics to measure their performance. And here we will mention some frequently used metrics for the classification, regression, and the clustering for you. And for the classification models, when we are evaluating their performance, we have to define a very important matrix. It's called confusion matrix. What is the confusion matrix? Here we show an example of the confusion matrix in this page for the binary classification. We assume we only classify the data instances into two classes, positive and negative, right? Depending on the true labels as well as predicted labels for instances, we can assign each data instance into one entry into the matrix. What does this mean? For example, if one data instance originally it is positive, in other words, it's the actual positive, and the model also predicts this instance to be positive. If so, we can say this will be a true positive instance. Right? However, if an instance originally it is positive, however the model predicts the instance to be negative, then it will belong to this false negative category. For instance, originally it is negative, however the model predicts it to be positive, it will be a false positive, right? And for the instance originally is negative and we also predict it to be negative by the model, then it will be a true negative, right, instance. So for all the instances in the data set, they can be partitioned into four categories: true positive, false negative, and true negative. And we can also count the number of instances in each category, right? So in this way, we can define this confusion matrix for classification problems. And we can get a number of instances which are in the true positive, number of instances in the false negative, in the false positive, and the true negative. And based on this number of instances, we can define some evaluation matrices. The first one we can define is called accuracy. Accuracy measures the number of instances we are classified correctly, both negative and positive, right? So in other words, we can define the accuracy to be true positive plus true negative over the whole dataset size, right? Because this numerator will be equal to the whole dataset size, right? Besides accuracy, we also define the precision. What is the precision? Precision measures, among all the instances which are predicted to be positive by the model, how many percentage of them are the true positives? In other words, by taking this column from the confusion matrix, how many percentage of them they are true positives compared with false positive? You can follow me, right? For example, if I predict this patient to be healthy, how accurate I am? So this is called precision. Another one is called recall. What is recall? Recall considers among all the original positive instances, how many of them can be detected? Among all the actual positive instances by the model, how many of them can be detected by the model compared with false negative? You follow me, right? So recall is defined to be true positive over true positive plus false negative. You can see the difference between them, right? Besides the precision and recall, we also have another metric. It's called F beta score, which is the balance between the precision and recall. F beta score is defined as this. We have beta as a parameter. Beta can be any number, 1, 2, 3, 4, right? And we have 1 plus beta squared times precision times recall over beta squared times precision plus recall. Normally, this F1 score is frequently used, actually. In other words, we can assign this beta to be 1 instead. So this F score is more like the balance between precision and recall. Normally, when we are doing the classification, we have to consider all of them as an evaluation metric. Besides accuracy, precision, recall, and F1 scores, we also have some other metrics like ROC curve and AOC, right, as a metrics for evaluation purposes. And you can refer to some external resources for the definitions by yourself after class instead. Okay, this is about classification. How about regression? For the regression, we can also define some evaluation metrics for measure the performance of the models. For the regression, we can define these metrics in different ways. This is same according to the model. We can predict the output of the model for all the data instances as y hat. At the same time, we can also organize all the data instance output as y this vector. Based on these two vectors, we can define different matrices according to some statistical knowledge, right? For example, we can define this explained variance as the evaluation metric. It equals to 1 minus variance y minus y hat over the variance of y. We can also define this MAE, or the mean absolute error, as the evaluation metric. It equals to the mean values of the y minus y hat, the absolute value, the summation, right? We can also define this mean square error as the metric. It is similar to the MAE, however here we have a square here instead. And we also define this median absolute errors as well, and R-squared score and eccentric for the classroom model evaluation purposes. Okay, so this is for the supervised cases. How about this unsupervised case for classroom? And based on classroom, we can define different metrics for the evaluation purpose. In this page, we show two, right? These two will rely on several components or several concepts. And before we introduce these two metrics, we can define 4 concepts based on the clustering results as well as distance measures. The first concept is called average distance within one single cluster. You can check here, right? And the second one is called diameter of the cluster. We will define the inter-cluster distance between 2 clusters and an inter-cluster center distance between 2 clusters. So by defining 4 concepts, we can define 2 metrics for evaluation purpose of the classroom models. The first one is called dB index. Another index we can define for clustering evaluation purpose is called Dewey index. The formula is also provided here. It's also based on the metrics we defined before, as shown here. I mean, we have to use this diameter of the clusters as well as the distance among clusters. So, for most of the tasks to be studied in this course, they will be based on classifications. So please make sure you can understand these kinds of metrics for classification problems very well. And for the regression and the clustering evaluation matrices, you can also check them carefully by yourself after class to make sure you are familiar with them. Okay, so generally that's it for this section, and then let's draw a very quick summary for this section. In this section, we have introduced what is machine learning for you, right? And we also show you the pipeline diagram for the machine learning problems. We have spent a lot of time on talking about the supervised learning, covering both classification and regression, right? We mentioned how to define the training set, testing set, and how to divide them. We talk about the SVM machine model, right? And for the regression, we have mentioned what is the linear regression model, the ridge regression, and lasso regression. For the unsupervised learning, we have been introducing the K-means algorithm for partition the data instances. And we also introduce what are the evaluation metrics we can use for the machine learning model performance evaluation purposes. So, I mean, after class, please make sure you can go over the reading materials as well as the lectures carefully to make sure you are familiar with what we have been introducing here. And we have some after-class tasks for the readings, reading the corresponding chapters in the textbook, and also reading the machine learning overview articles. And for the project, start to look for your teammates, and also learn Python and also install the PyCharm and set it up. We will start to do the stage 1 for the project in the next week, so make sure you can finish learning of the Python and also have the PyCharm installed already. Okay, so that's for this section, and thanks a lot for your attention. Welcome to let me know if you have any questions.